Okay, so let's talk about our next section, 9-4. This is where we're going to do a little bit more equation solving. But instead of what they looked like before, where they all started with in logarithm form, we're going to start without the logarithm form. I'll show you what that means in a moment. All right, let's look at maybe a few review first. Just recall that, yeah, we do have a way of solving these. Remember what this actually is asking. Okay, this is asking 3 to what power is 81? So many of the times so far we've been able to maybe just consider this question, look at it, and say, okay, well, 3 times 3 is 9, times 3 is 27, times 3 is 81. So yeah, 3 to the 4th equals 81. Okay. We had another way of looking at it, and that was if we can write 81 as an exponent. For the base of 3, we'll get the same answer. So we can write 81 as 3 to the 4th. Okay. Remember, anytime you have an exponent with a logarithm, it's the same as multiplying. Okay. And then, of course, 3 to what power is 3? That'd just be 3 to the 1 power is 3. So we get 4 times 1, which is also 4. So we get the answer either way. We're going to look at yet another way of getting this answer, and that's more of a calculator-driven approach, and that's called the change of base formula, which basically means we're going to do the log of 81 divided by the log of 3. So log of a number here divided by the log of the base, and we don't use a number here in your calculator. It's automatically going to be considered a base 10. Not that it's important, we could use any base here and you'll get the same answer, but without the number given as a base, it's going to be base 10. So this is going to be our third and final way of getting an answer for a logarithm. Okay? And the same thing applies before. Like on a problem like this, we had to do a lot of work. Instead of doing all that work, we simply need to, in a calculator, do log of 16 divided by log of 8, and that'll give us the same answer as if we broke it down into pieces like we have been. One quick note that this is not the same as the log of 16 over 8. Okay, these are not equivalent; they're not the same. This technically means, remember, when you're dividing, that's like subtraction. That means the log of 16 minus the log of 8. So depending on what kind of, if there's 2 logs, it's different as if there's just one. Okay? One is actually log of 16 divided by 8. One actually, the other one, right here, means the log of 16 minus the log of 8. So we don't want to confuse those. All right, here's a proof for the formula I just introduced, where we can just say the log of any number with any base is just simply log of that number times the log of that base. So that's the formula. Okay, let's move on. All right, so real quick, you want to verify on your calculator that you can do these calculations. Once again, remember that automatically with your calculator, the base is going to be 10, okay? And that will work for the majority of our problems. So on all of these, there is no base on them, but it's by default 10. It's called common log. Okay. Yeah, I just want to verify everything works. Remember, these are rounded answers. Anytime you get a decimal like this, it's rounded, so these are technically approximations. You'd want to use approximate sign, not an equal sign. Of course, if you have a calculator, some calculators you can just plug in this entire expression in the calculator, hit enter, and then get the decimal. That's the kind of calculator you want. You might have one that you can only do one function at a time. Just be very careful with your decimals and show all the work. Don't want you missing anything just because of your calculator is not completely familiar with it. All right. We'll just go through that. All right. So what we're going to do, I'm going to show you 3 problems. Going to introduce solving equations using logarithms. You use logarithms anytime your variable is in the exponent. Okay? And we're going to do something similar that you've probably used to, and it's kind of like adding to both sides, subtracting to both sides. You might remember you can raise both sides to the same power, and now we're going to introduce taking the log of both sides. Okay? The purpose of the log on both sides, and why we use it and why you need it, is when the variable is in the exponent. So once you take the log on both sides, we do have this formula that says, or the shortcut that says, we can move any exponent down here in front, right? And now we can solve as we normally would. So it's important to realize with all this logs and a lot of stuff, this is no different than something like x times 2 equals 4. I write it this way because the variable's first over here, but log 6 is just a number, like the number 2, and log 42 is just a number, like the number 4. So if for this problem we'd look at it as 2x equals 4, we'd solve it by dividing by 2 on both sides, and then you have x equals 2 as our answer. So same idea here. Instead of the number 2, though, we have the log of 6. So we're going to treat these logs just like the numbers that they really are. Divide both sides by log of 6. Log of 6 divided by log of 6 is 1, and they cancel out. Just like 2 over 2 equals 1, they cancel out here. So very similar structures. It's just that we have these logarithm numbers instead of our usual integers. And of course, from this point on, it's an approximation. You put this in your calculator, log 42 divided by log 6. You do not need the base. Okay, you do not need the base. And you'll get your decimal. Let's see if I can approximate it. Let's see here. I'm going to do clear mine. So I'm going to do log 4. Actually, we have the log of 42 over the log of 6. Okay. And that's approximately 2.086. 2.0860. And we're going to go to 4 decimal places as a general rule. Looking back, you can probably estimate that just roughly. Okay. If we know 6 to the second power is 36, 6 to the third power is like 218, so we expect this number to be a little bit more than 2. So our answer is confirmed and agrees with that estimation. Right, so that's one of the easier types of problems. Just like solve 2x equals 4 is relatively easy. It's one step. We have more than one step, but the structure is fairly simple. So we're going to look at 2 more. Okay. And you can see, how do I know this is kind of the middle? Well, it's kind of like I have x minus 5. So it's not just x like the last problem, but got a little bit more to do. But the process will be the same. I'm still just going to take the log of both sides. It's inequality this time. Okay. Once again, we have a property that says we can bring that in front. I'll use parentheses here. Okay. Now I still need to get x by itself. Okay. Now think of it as, let's see, a good type of problem here. How about 12 times x minus 5 is greater than 9? I'm just using similar numbers, but this isn't anywhere related to the right answer for this. But the structure's the same. So think about how would you solve this? You distribute, right? You get 12x minus 60. You would add 60 to both sides, divide by 12. We're going to do the same thing here. Instead of distributing 12, we're going to distribute log of 12. And notice it's behind it, so it'll work this way. So we have x log of 12, x log of 12, minus 5 log of 12. Okay. Same idea, just distribute. Then we'd add 60 to both sides. Here we're going to add the number. Just add 5 log 12 to both sides. Oh, you know what? I totally forgot to put the log over here. Yeah, we did do the log of both sides. So add the 5 log of both sides. So right now we're looking at, so now we have x log of 12 is greater than log of 9.32 plus the log of 5 log 12. Okay. And one last step, like here we'd add 60 to both sides, then end up dividing by 12. So we're going to divide by a log of 12 both sides. Now you notice on the right hand side, I'm not simplifying this. I'm not trying to find out what decimal log of 9.32 is and what decimal 5 times log of 12 is. I'm just going to leave it as is. And my hope is that you have a calculator, now we just have x. Okay? You have a calculator where you can just plug in this entire expression. You're not going to find one decimal at a time. Okay? But once again, here, you just want to be able to type in the entire expression. Log of 9.32 plus 5 log of 12 all over log of 12. And this type of calculator ensures you're not going to have any errors just by entering things the wrong way. And then we get our answer. 5.898, and then I'm going to round up. And there we go. So again, we have to always use this property in the very beginning. That's why we're taking the log, is because right after that we can bring it down. And then if you have a single term like the last problem, single term, it's just a matter of dividing. It's kind of like 2x equals 4. You just have to divide both sides by whatever log is next to the x. If you have something like x minus 5 or x plus 4, you'll have to distribute first, just like you would have to distribute here before solving for x. And then we have the final type of problem we'll look at, and this is when you have variables on both sides. Alright, so let's start this. Again, take the log of both sides. Okay, exponents come on down. Y times log of 4 less than, let's see here, I'm going to put 2y plus 1 in parentheses times log of 5. Okay. Like we did on the last problem, I'm going to need to distribute. So the left side stays the same. So we have 2y log of 5 plus 1 times log of 5, which is just log of 5. Alright, so think of this we got a variable here, just a number here. So think of it as something similar to, let's say, 4y less than 2y plus 5 or something. We just have to get the variables to the left, numbers to the right. We'd subtract 2y on both sides. Minus 2y log 5, both sides. So just numbers over here, now variables on the left. And don't get distracted that there's a lot of these logs floating around. They're just regular old numbers taking up space. So now we have y log 4 minus 2y log 5 less than log 5. Now, what I'm going to do next is factor. Okay? I'm going to do something, I'm going to factor. Take this y out, take this y out. So now I have this log of 4 minus 2 log of 5 less than log of 5. I'm going to divide both sides by that part in parentheses. So divide both sides by this long number. Now, if you happen to do a different method and you end up with a correct answer, that's probably okay. At this point, there are many properties we could use that might, not necessarily be faster or easier, but just different ways of going about it. So if you're looking at this and you say, I got this other way that will, maybe makes more sense to you, but gets the same answer and consistently gets the same answer, you can just go ahead and use that. All right. Alright, and then I'll let you put that in the calculator and calculate the decimal. Alright, follow up, yeah, and that's going to be it. So, good luck. It'll take a little getting used to. I guess you might want to recall, just for the last few, because I didn't do any that had a square root in them, but hopefully you recognize that a square root is simply the 1/2 power. So we can still go ahead and calculate, okay, n minus 2 over 2. So if I just basically move this 2 to be underneath here, so now you have a single exponent. So yeah, square roots are just simply half powers. And the same rules apply. All right, good luck.